Well, welcome everyone to this episode of Build America, the national podcast that's capturing and sharing the very heartbeat of construction and development. I'm your host, Kerry Smith, and we're delighted to welcome Kyle Kammer to this episode, which we have dubbed Lessening the Carbon Footprint. And Kyle is Director of Quality for Concrete Strategies, and that's the nation's 8th largest concrete contractor. Kyle also heads up Concrete Strategies' sustainability efforts in tandem with the Clayco enterprise and large clients. They deliver the most sustainable projects possible. Kyle, welcome to Build St. Louis. We're really glad to have you on this episode.
For having me.
You bet. You bet. And so we've dubbed the topic Lessening the Carbon Footprint. And I saw a statistic recently that really caught my attention, Kyle, about cement and concrete the other day. It was in the Scientific American, and I'm sure it's been in other places. But the reference was that every year worldwide, cement and concrete production generates as much as 9% of all human CO2 emissions, carbon dioxide emissions. Or in other words, each pound of concrete releases nearly 1 pound of carbon dioxide. And I wondered if that's true, if you could just kind of give us an overview in terms of overall understanding. Is concrete in itself sort of the biggest emitter of CO2, at least within the construction environment?
So it's kind of a tricky question. So it is one of the major producers in the world. And the reasoning for that is that concrete is actually the most used building material or material on Earth besides water.
Wow.
We use more of that as an industry worldwide than any other material. If you look at it on a pound for pound basis compared to really any other building material, it is actually quite green. And then you got to kind of look at a whole life cycle of a building, right? If you build a building out of wood or steel, it might last for a while, but generally concrete structures are going to last significantly longer. They're going to be a lot more resilient against natural disasters and things like that. So you got to look at it from all aspects.
Sure. Sounds like you said a life cycle thing, because if you're building that building 2 or 3 times over with steel or lumber, wow, that makes a lot of sense to me. I appreciate you delving into that. I know the concrete industry seems as if it's making tremendous strides with research and development. As you mentioned, green concrete. I'd love to have you talk to us about what green concrete is and how that plays into the equation of sustainability.
Well, you put some color pigment in and you turn it green. No, really, we as an industry are kind of realizing that it is having a major impact worldwide. And again, take that with a grain of salt, because like I said earlier, it is generally one of the more green building materials, and we use a lot of it. There's a lot of things that you can do to sort of lessen your carbon footprint within the specs, I guess, that you're given as a contractor, and that's usually what we have to deal with. But you can replace, you can substitute, you can use different chemicals to increase certain properties of the concrete or reduce certain properties of the concrete. So there's a pretty good bevy of options that you have available. Obviously, the earlier you get into that process, the better it's going to be, the more opportunity you're going to have to really lower that carbon footprint. It's something I've been kind of pushing on an industry level, as I do my industry events through the year. And we really have to push for earlier contractor involvement, because by the time it makes it down to the contractor, if it's just a standard run-of-the-mill hard bid, our options are quite limited as far as what we can do. Whereas if we can get in early and talk with the structural engineers and get a feel for what the owner actually wants to do and have those conversations, it's going to be a lot easier to manage that. The contractor, I guess, can't bear the cost 100%. There's some things we can do that are very little to no cost, but ultimately, if you're wanting to go like a true carbon neutral on a building structure, that will cost money. It'll either cost money or it'll cost time. And that's something that owners need to recognize and try to work within that frame to achieve the result they want. But ultimately, we can be as sustainable or not sustainable as the owner is really willing to afford.
That makes sense. Back up a little bit for us, Kyle, for those of us, and I definitely include myself in this group, need a little lessening concrete 101. So maybe if you could just really kind of, for lack of a better phrase, dumb it down for us in terms of the properties that comprise traditional carbon-centric concrete versus green concrete, so we can kind of understand the differences in just the makeup of the product itself.
All right. So concrete is generally made up of sand, coarse aggregates, larger stones, cement, and water. Those are generally the 4 main building blocks of concrete as a material. And now modern day concrete usually adds in some admixtures, water reducing admixtures, air entrainment, retarders, accelerators. There's a lot of different options there, but those are generally the 4 building blocks of concrete per se. Almost all of the carbon within the concrete carbon footprint comes from that cement. And it's a very, very energy and very intensive process to make cement. If you've ever get a chance to go out and like see a cement mill, it's pretty impressive. Giant kiln, huge amount of heat and energy transfer there, but it's a very, very cool. I've been to a couple of them, and it's always a really cool thing to see. But again, we're trying to essentially lower the amount of cement we're using, or use other cements, or substitute cement with other materials such as slag, fly ash, metakaolin. A lot of those materials are byproducts of other industries. So slag comes from the steel mill industry. Fly ash is a byproduct of coal-fired power plants, which obviously are kind of in decline right now. Metakaolin is another option that's probably less used, but that's sort of a naturally occurring clay pozzolan. There's a couple others, silica fume, a few other things that people are starting to use. Obviously, the market's shifting, so the developer incentive is there to create new materials. You're starting to see things like ground glass pozzolan, which is basically recycled glass that's being used in there. There's a few new types of cement being developed. The industry almost completely shifted over to the 1L cement, which is a higher limestone content cement, which is a little bit less carbon effective. And there's some more performance-driven cements that are starting to come out on the market now. There's alternative building materials. They're seeing some geopolymers, things like that. So there's a lot of really cool stuff happening. I'm not, expert on all of it. I'm just trying to take it as it goes. But there's generally, you're trying to lower the amount of cement in your mix. And that's really what's going to affect the most amount of carbon savings, if you will, per pound or per ton.
Perfect. That's so helpful to understand. And so if a contractor, or I guess a developer or owner, makes the choice, Kyle, to go with a more green process, how does that compare or contrast to the project delivery of the actual, when all the trucks show up and they're doing a pour on a huge warehouse distribution center or what have you? How does that impact in terms of ideal temperature, the time it takes, the dry time, and all that good stuff?
It can have little to no effect. And again, I think it's a matter of how far ahead of things you can get. And again, kind of going back to the early involvement, if we can kind of all come to the table and come to an understanding and understand expectations, set forth expectations, and then understand what it's going to take to get to those expectations, generally you can do it with almost no impact, but they're schedule wise, but there may be a cost. Or conversely, you can throw a bunch of extra slag in the mix and you really lower your carbon footprint, but you'll have to wait for a lot longer to get your strength development so that you can actually use the building or move on with your schedule. There's a lot of different options. And you kind of remember that little like triangle. You can have it good, you can have it cheap, you can have it fast. You can have two of the three, but not all three in general. And it's kind of a similar situation.
Can you point to any projects that are maybe high profile that we might be able to relate to pretty much anywhere in the country, but where they have sort of been on the pioneering end of using more of the green mixes?
I mean, I'm trying to think of some we've just started seeing as an industry, designers putting in carbon budgets or like global warming potential goals or requirements. It's fairly new. I think we've gotten two within the last few months. Neither of them has started up yet. We've got a job for an airport in Indiana somewhere, and there's actually some goals, and we've had to work with the ready-mix supplier to make sure that they have an environmental product declaration actually documenting all the carbon that went into each unit of, in this case, it'd be cubic meters or cubic yards of the material. And we're working to meet those goals or exceed those goals. We're also kind of involved in some industry research, trying out new mixes. I mentioned some new cements. We're working with a pretty big ready mix supplier from the Chicago area to try out some new cements. It's a ASTM C1157, which again is more performance based, but it's very, very low carbon footprint when compared to a traditional cement. So,
and you ran through a couple of initials there. What were you saying? ASTM? What was that stand for?
It's just the American, I'm going to get this wrong, American Society of Testing Materials.
Okay, very good.
It's basically just the standards, and they have all the standards for the testing, the performance criteria for most materials or processes or tests within at least our industry. I know they kind of go through all the industries basically, but it's generally just a widely accepted test method or requirements. So
sure. Are there federal or state incentives for, I was thinking about this when you mentioned the ready mix companies and everybody needing to work together and be incentivized to pour, I'm sure, money and a lot of time and smarts into R&D, research and development for this. Are there any sort of financial incentives under any government entities that help, I don't know if subsidize is the right word, but help incentivize companies to look for newer and better ways?
I'm sure there are. I'll be honest, I'm not necessarily my area of expertise. I know there are starting to be some requirements. I know in New York, New Jersey, California, kind of curious seriously. I think a little bit behind them, but there are actually a few states that have passed, laws saying if you do any state work, whether it's highway work, buildings, whatever, it shall have less than this carbon footprint per yard of concrete or per cubic meter of concrete.
Okay.
And maybe that's not an incentive, but if you don't do it, then you're penalized somehow. It doesn't really line out. Most of the laws are pretty vague right now. So I think there's kind of a realization that it is a new process. It's just generally it's new in the industry. So we're having to really relearn how we're doing all this to stay compliant.
I bet you companies that do our departments of transportation are really feeling those requirements on heavy highway and other projects and interstates and bridges.
The GSA from a federal level, Government Services Association, they've also set forth some goals. And, the initial goals are pretty, I'd say, achievable. They're not really pushing the envelope as of yet, but I'm sure that's coming. So I think they're really trying to get everyone on board with being able to track and report on their EPDs. So.
Certainly. And it seems like it would be somewhat of education requirement to maybe for less savvy project owners, just to kind of really lay that out for them in terms of bottom line. And like you said at the beginning, the life cycle benefits. Is that, like you said, a conversation that should be held early on so the owner has time to understand his or her options? Yeah,
for sure. And we're starting to see, we're not starting, we've been seeing some of the bigger players within the industry as far as the owners go, the Amazons, the Googles, the Microsofts, they're taking a very hard look at it. We've been working on some different committees with those individuals or those groups, I guess, to try to help them understand what it costs and like how everything's going to shake out, but also to try to understand where they're coming from, what their kind of expectations are. But we are starting to see that. But again, it doesn't necessarily translate down to some of the, like you said, maybe less sophisticated owners, and not just on the ownership side, but as well on the ready mix side, the material supply side. Generally, the bigger players are going to be compliant earlier just because they have the resources to kind of get ahead of things, look out ahead. But a lot of the smaller, maybe it's a mom and pop owned operation or just a smaller local supplier, generally they're not going to have the resources to really tackle it way ahead of time until they're kind of forced into it. So again, maybe it's an unintended side effect of the big change. But
right. I wondered if other project partners on the team, such as architects, mechanical contractors, electrical contractors, if the decision that may seem initially concrete subcontractor related really affects how the project is specified, designed, engineered. I bet it affects project partners way beyond those who are pouring the slab.
Yeah, I haven't seen it personally. Like you mentioned earlier, the onus and the focus is kind of on concrete right now. I know a lot of material suppliers or equipment suppliers, things like that, they are starting to, the larger ones at least, are starting to produce EPDs. We're starting to see that as kind of a trend in the industry. But as far as, and you think about it, like it's a lot easier if you're just producing one thing. A concrete supplier, they got to consider, where do they get my stone from? Where do they get my sand from? Where do they get my cement from? Sometimes it's multiple places. And so there's a lot of moving parts that go into producing an accurate EPD.
Tell me what that stands for. I don't know.
Environmental Product Declaration. So again, just reporting on how much CO2 is emitted or produced during the production of one specified unit of material. So in this case, cubic yards of concrete or cubic meters of concrete. But again, when you're considering you're getting multiple different sources, and sometimes that may change mid-job. If something goes down or the plant has a problem or the quarry has an issue, you may have to shift in the middle of a job, and that kind of throws all your numbers out. You got to kind of recalc. So
sure, that makes sense. If we're having this conversation maybe 2, 3, 4 years from now, do you feel that the methods and the options for sustainable concrete products are going to continue to expand? Is there anything kind of on the horizon that you're in your industry involvement, you're seeing people testing to see if that's a viable, sustainable material?
Yeah, I kind of mentioned earlier, you're starting to see some new research and new interest into like alternative supplementary cementitious materials, SCMs. So basically stuff that you can replace cement with. Ground glass pozzolan has been kind of one. It's actually been around for quite a while. It's just that, they're taking a harder look at it now. They're out now also looking at the use of like bottom ash instead of fly ash, which is just difference in carbon content. But again, a byproduct of the coal mills or coal plant fired power plants. And there's, a lot of just deposits of this that have just been kind of buried over the years. So they're talking about harvesting it. Again, there's also, looking at completely like no cement cement, essentially. And again, a lot of that's really cutting edge. And there's also, you're looking at a lot of chemicals and things that are really trying to help the concrete develop strength faster or more reliably. We're seeing a lot of new products on the market and trying to do the evaluation to make sure that we're doing our due diligence and protecting ourselves as well as the owner, and really evaluate the products. And we've been doing a lot of just testing and test labs and trying new materials out. I mentioned a couple of those earlier. It's becoming a lot more critical. And then just in general, trying out new mixes. I mentioned earlier the cement industry kind of shifted from producing type 1-2 cement to type 1L cement. And it's probably about at least 90 to 95% of our projects are now using type 1L. But making sure that we are doing test pours early, trying out new mixes because the cement is different. It's not necessarily acting the same way as it used to. It's becoming a lot more important just for our own sake. That way we don't end up ripping out a bunch of concrete. It's pretty hard to fix concrete after you pour it, turns out.
I would imagine. Gosh, I could talk to you all day. This is interesting stuff that all projects teams deal with, and all of us who drive by and see a big, Amazon or Google or other data center concrete pour, we see the trucks and we wonder what all the new and exciting sustainable possibilities there are. But we've been talking on this episode of Build America with Kyle Kammer, Director of Quality for Concrete Strategies. And Kyle, it's been a real pleasure learning from you in this episode. Please come back and see us again.
Will do. It was good talking to you.
Thank you.